Hello everyone, welcome back to my YouTube channel Summarize TI. As part of today's video, we are going to talk about splitter and retriever we have in LangChain. A splitter is a component or a process that breaks large document into smaller, manageable chunks so that a large language model can process them effectively. Large language models like GPT have a context window limit, which means chatbots like GPT can only remember and understand a certain amount of text at a time. If a document is too long, it cannot process it in one go. By splitting the document, you can feed the LLM relevant pieces one by one. Smaller chunks improve retrieval quality and accuracy when doing question answering or RAG. Now for every chunk, it creates its vector embeddings, which is a numerical representation of text and other data in a high dimensional space. Something like this list of numbers separated by comma. We can create vector embeddings using one of the embedding model like OpenAI's text embedding 3 small or text embedding 3 large. And this is the way we store the chunks and its vector embeddings in the vector database. Now, the main question is why do we need embeddings? Embeddings allow us to perform semantic search. Before we talk about semantic, let's first understand traditional keyword search. Traditional keyword search looks for exact words in the string. Suppose I have these sentences and I want to find the one containing Python or LangGraph. And for that, I can perform a simple keyword search. But if I try to search for programming language or framework, it will not give me the response because there is no keyword matching. On the other hand, vector embeddings allow meaning-based search, which we call as semantic search. It will provide semantically similar text that are close to each other in this vector space. Either you search for Python, programming language, AI, or LangGraph. It will provide the response with relevance score. The relevance score indicates how closely each result matches your query. If we search Python, the sentences that contain the word Python will have a higher relevance score. For instance, the first, second, and fifth sentence have higher relevance score because they directly mention Python. But on the other hand, second and fourth sentences have lower relevance scores even though they are related. For example, LangGraph is developed by Python because they do not mention the word Python exactly in the main context. The relevance score helps indicate how closely each sentence matches the search query. Now, let's talk about the retriever and how it works, which is responsible for fetching relevant information from the database based on a query. In case of search or query, the query is first converted into embeddings using the same embedding model that was used for the content. The query embeddings are then compared with the embeddings stored in the database. These query embeddings are then compared with the embeddings stored in the database to find the most relevant content. The comparison is typically done using similarity or relevance metrics such as cosine similarity, which measures how close the query is to each content embedding in the vector space. Content with higher similarity scores is considered more relevant, while content with lower scores is less relevant. And this is how the splitter and retriever works. Let's try to understand one of the splitter and retriever implementation use case of semantic search and RAG application. We will first start with splitter. Assume we have documents or JSON data that needs to be converted into embeddings and stored in a vector database. Assume we have documents or JSON data that needs to be converted into embeddings and stored in a vector database. Create smaller chunks for the content present in the document or JSON data by using one of the embedding model. This embedding model will help us to generate vector embeddings for each chunk. And as we know, embeddings are nothing but the sequence of numbers separated by comma. Now, store both document content and its vector embedding in the PG vector database, something like this. Now let's discuss the retriever, which is responsible for fetching data from the database based on a user query. First, the user submits a query. The query is passed to the same embedding model. The model creates an embeddings for the query. And as mentioned earlier, embeddings are numbers separated by comma. Now, in the last step, the query embedding is compared with the embeddings stored in the vector database. A similarity comparison gets performed to identify most relevant matching scores. Once comparison is done, retriever returns the result to the application. And this is how the splitter and retriever works together. Now let's go to the Visual Studio and start our implementation. Before we start our development, we require PG vector database to be available in our local. To install this PG vector database, I have already created this particular video. It is a very detailed video which will allow you to install the PG vector database in local in less than 10 minutes. Now we can go ahead and start our development. Let's create a file, splitter underscore retriever.py. We require some of the third-party libraries to be available in our local before we start the development. So for that, we can say pip install langchain underscore OpenAI. So we are going to use the OpenAI from LangChain to create the vector embeddings. Okay. Now, after this, we require LangChain underscore text underscore splitters, which will allow us to create the chunk of text. Okay. Now, the last one we require is to connect with the PG vector database. So there we require the Postgres. Okay. So to install these libraries, what we can do, we can copy this command and paste into the command prompt or the terminal of your IDE and hit enter. It will allow you to install this library. Similar thing we can do for rest of the libraries. Just copy and paste in the command prompt. Here you see I'm getting one message, requirement already satisfied. I'm getting this message because this particular library is already installed in my local. You may or may not be getting this message depending on the availability of library in your local. Great. Now let's go ahead and start the development. So let's make some imports. So the very first import I'm going to make is from the LangChain text splitters. So from LangChain text splitters, we require to have recursive character text splitter. Good. Now from LangChain underscore OpenAI, we require OpenAI embeddings. Now the last one is from LangChain underscore Postgres. We require the PG vector. Good. Now PG vector. Last one we require is import operating system OS. So now as we are going to use the OpenAI, we require the API key. So what we can do here is we can say os.environ OpenAI underscore API key. Let me go ahead and copy paste the API key. If you wish to create or generate this API key, you can go ahead and check out my video. There you will be able to generate this API key within 2 minutes. So let's proceed further. Once we have the API key, now to connect with the PG vector database, we require the connection details. So let's go ahead and create those details. So here we can say database underscore URL equals to PostgreSQL. And then here you can provide Postgres as the username and the password is admin, and we are going to use the localhost PG vector database, and which is there on the port 5432, and this one is nothing but the database name under which we are going to create our collection. So now provide the collection name also here, which is nothing but it represents a kind of virtual table, LangGraph underscore docs. Great. Now we require data which we can go ahead and create the chunks and store in the vector database. So I am having this raw document. Okay. So point to be noted here, this document, what we are using currently, it's a very short document of 2 lines. We might be having a document which may have 10,000 or 5,000 lines. Okay. So I'm just giving an example here, just a sample. We have this sample JSON data and it's discussed earlier. We have to split this JSON data into chunks, and those chunks we are going to convert into the embeddings, and those embeddings we are going to store in vector database. So let's go ahead and use our recursive character text splitter, which will allow us to create the chunks. So let's do that. Here you can say chunk underscore size equals to 50, and then comma, you can provide the chunk underscore overlap equals to 10. This way, we will be able to create the chunk having an overlap of 10. Now, what this overlap is, suppose we have this complete string here, okay? And what this recursive character text splitter will do, it will create a chunk of 50. And whatever it will get remaining, then it will create the chunk of that particular content. Now, while creating a second content, okay, it will take the overlap from the first one. So for example, in my first string, I have this as a text. So it will create the chunk up till here, just an example. And then when it will create the second chunk, it will take some overlap from here. Okay, so it will take overlap from here. So the next chunk is going to be this much. So the first chunk is LangGraph is a framework for building. Now here the for building will get repeat because the chunk overlap size is 10 and 10 here is nothing but the number of characters. Okay. And similar to this, it will do the same things for the subsequent thing. So it will create chunk something like this. So it created the chunk of 50 here. Okay. And if you see in the first string, this is the size of 50 and it took some characters from the first chunk here. Okay, so this is nothing but a overlap. Similar to this, if you see here, reg retriever relevant documents from a vector. So a vector is getting an overlap here. Overlap ensures the important information at the boundary of two chunks is not lost when processing text with limited context window. Now let's create an embedding model which will allow us to create the embeddings for these chunks. You can say embedding underscore model equals to OpenAI embeddings. And here you just provide the model name. So model equals to text hyphen embedding hyphen 3 small. Now we have the embedding model with us and the splitter. What we can do, we can create the chunk of this raw document list. So let's go ahead and do that. Before we create the embeddings, let's create a list under which we are going to keep all the embeddings. Now loop through the list. So for doc in raw documents, and here you just say text dot extend, and inside it you just say splitter dot split text and pass this doc here. Now what we can do, we can create a connection with the PG vector database. So for that, we are going to say PG vector underscore store equals to PG vector. Now this PG vector require 3 arguments. So the very first one is the connection, and connection is nothing but our connection string what we have given here to connect with the database. So provide this particular string here. And then after this, we require embedding model. So you can say embeddings equal to embedding model. Okay. Now after this, we require the collection name, which is the virtual name of our table, what we have declared here. Good. Now our PG vector store is ready. And what we can do, we can simply say PG vector dot add text and just pass the tag simply. Once we have this, which means our document successfully stored in the PG vector. Let's print the statement here and say documents successfully stored in PG vector. Great. So let's execute this piece of code and see the output. Before we execute this piece of code, let me go back to the PG vector database and show you. So these many tables at current point of time is available in my vector database, which is not related to the current video. So let me go ahead and execute this piece of code. Okay, we are getting some error. Port 5432 failed fatal. Password authentication failed for user. Postgre, oh no, sorry, not Postgre, it should be Postgres. Let me save and again execute this piece of code. Now you can see the code successfully got executed. We got the message documents successfully stored in PG vector. Now let's go back to our PG vector database here and refresh this table section. You will see two tables got created. The very first one is langchain underscore PG underscore collection, and the second one is langchain underscore PG underscore embedding. If we select langchain underscore PG underscore embedding, let's see what data we are having. So here we are having an ID, collection ID, embedding, and the chunk. Now here, if you see this collection ID, okay, and if I select this PG underscore collection, this is the collection name we have given, which means whenever we are going to work with the splitter, it will create two tables out of the box, which is inbuilt provided by LangChain. It will create LangChain underscore PG underscore embedding and LangChain underscore PG underscore collection. So collection will have the details of the collection and the UUID, and this UUID will get refer in the PG underscore embedding. So for this particular collection, we have this data here. Okay, and this is the collection ID which got created by LangChain. So this is how they create the tables and collection and provide a reference of that collection into the embeddings. Good. And you can see this is nothing but chunks it created. So here if you see the chunk, when it created this particular chunk, it took the overlap of a vector in the next chunk. And this is how this overlapping works to provide the more context to our LLM. Good. Now let's go back to our Visual Studio. Now let's work with the retriever to retrieve the information. And for that, let's write down a query. So query equals to what is LangGraph. Here, just say retriever equals to pg vector store dot as retriever. So as retriever will help us to retrieve the documents. So now here you are going to provide one argument, which is nothing but search underscore kworks, which represents how many results you require in return. So here if I provide number as one, then the number of results I am going to get the one, which is like more relevant to my search. So let's see that. Now here you can again say docs equals to retriever dot underscore get underscore relevant documents. Okay. Mm, pass your query here and then say run manager equal to none. So we don't require a run manager. And you can write down a loop because you are going to get the multiple documents. So you can say for doc in docs and just print the result doc.page underscore content. Okay, so let me execute this piece of code. So I'm going to remove the embedding because we don't require embedding, is already done. Okay, so let me execute this piece of code. So what it will do, it will go to the PG vector database. It will retrieve those many number of documents and it will return only the relevant document, which is this one it returned. LangGraph is a framework for building stateful AI. Now, if I change the value from 1 to 2, then it will be returning two results to me. Yep, you can see the first output is this one, which is more relevant. And after that, it provided this also because this is also related to the LangGraph. And this is how a splitter and a retriever work, where we can split the documents and retriever help us to retrieve the relevant information from PG vector database. Thank you so much for watching this video. Please don't forget to like and hit the subscribe button.